Question number 27. A sound wave of wavelength 0.5 meters lambda is given, passes through a doorway of width d is given. Okay, between two rooms, which change increases the amount of diffraction? When is diffraction possible? Diffraction is possible only when lambda is nearly equivalent to or greater than the value of d. Okay, the wavelength, okay, which you sent, the wave should be larger than the obstacle size. Okay, so you would have learned something about it in case of a loudspeaker. For example, you have a loudspeaker here, you have a mountain here. What can happen? The loudspeaker's waves will go only until here, get reflected back here, right? But if suppose if we had a wavelength whose frequency is smaller, wavelength is larger, it could have passed over here. Radio waves, for example. Okay, now let us read this. Double the amplitude. Amplitude does not matter. Double the width of the doorway. No, d should not be increased. Hey, this is lambda. Lambda here is less than d. I should increase the value of lambda. That's the question. That is not right. Either you increase the value of lambda or decrease the value of frequency. Right? Either of them are correct. Half the frequency. When you half the frequency, what will happen to wavelength? Wavelength will double, which means it's nearly equal to 1 meter. Therefore, this is the right answer. C is the right answer. Period. Half the period of sound wave. What will happen? When period is half, t by 2 it becomes, then frequency becomes 2f. When 2f it becomes, then lambda becomes lambda by 2. Right? So therefore, this is also not the right option. So C is the right option.